grow up to be like Walter White?
Hello, men. Welcome to Periodic Trends. We're going to talk about 3 trends on the periodic table. Basically, for each one, we want to know, does it increase as you move to the left or to the right on the periodic table? And does it increase as you move up or down on the periodic table, and why? Our 3 trends are atomic radius, electronegativity, and ionization energy. Atomic radius is just the size of an atom. It's literally the distance from the center of the nucleus out to the outermost shell. As we look at the periodic table, this trend increases as you move down. So oxygen is smaller than sulfur, which is smaller than selenium, and so forth. So we can write that it increases as you move down. The reason is that each time you move down a shell, the electrons are filling out a new shell around the atom. So electrons fill up a new shell. Imagine that you're moving across from boron to carbon to nitrogen to oxygen to fluorine to neon. You're not really filling up any new shells as you do this. You're just still filling up this same 2p subshell. Now, when you get to neon, the 2p subshell is full. You can't put any more electrons in it. The very next atom has to put an electron out in the next shell, which means you just went from this, 2 shells, to boom, 3 shells, and the atom just got a lot bigger. That happens every time you move down a period on the periodic table. What's less intuitive, possibly, is moving left to right and seeing which way gets bigger. Imagine again I go from boron to carbon to nitrogen to oxygen. As I move to the right, I'm not getting any new shells, but what I am doing is adding a proton to the nucleus. I go from 5 protons to 6 to 7 to 8 protons. And all those positive charges in the middle serve to attract in the electrons and suck that into a tighter and tighter sphere. So atomic radius increases a little bit actually as you go to the left on the periodic table. Why? Because more protons create greater attractions between the nucleus and the electrons. We can see then that francium down here in the corner would be the largest element on the periodic table because it's the furthest one down and to the left. Alright, electronegativity literally means love of electrons. We want to know which atoms want electrons more, the ones on the left of the periodic table or on the right. Well, let's consider group 17 here with fluorine, chlorine, bromine, and iodine. All the atoms on the periodic table want 8 valence electrons. They all want a full outer shell. Well, fluorine and chlorine and bromine and iodine almost have that. They only need 1 more electron to become like neon, argon, krypton, and xenon. They desperately want that 1 more electron, and so we say that they're very electronegative. On the other end, we've got group 1 elements like lithium, sodium, potassium, and rubidium that have only 1 electron in their outer shell. They are actually going to look to get rid of it and have the shell below that be their outer shell because it's full. Which means that these guys are trying to get rid of electrons. They do not have, therefore, a very great love of electrons or a very high electronegativity. So electronegativity is going to increase a lot as you move to the right across the periodic table because of the octet rule, which states that atoms want a full outer shell. Now, what about going up or down on the periodic table? What if we compare fluorine and iodine? They're both in the same group. They both desperately want one more valence electron, but they're different size atoms. Iodine's a lot bigger than fluorine. Look at their picture. I've got fluorine on the left here. It's got 9 protons. It's got 2 layers of electrons around it. The outer layer has 7 valence electrons, desperately wants one more. Iodine is drawn on the right. It's got 53 protons, and it's got 5 layers of electrons. The outer electrons are still 7, which means it desperately wants one more. Now, imagine this lone electron here that's available to be captured by one or the other of these ions. Now, the thing that's in an atom that can actually attract electrons are the positive charges in the nucleus. Who can get their nucleus closer to this electron? Obviously, fluorine can, because it doesn't have as many shells. Not only that, not only can it get closer, but all these other electrons in the 5 layers in iodine serve to repel the electron that it's trying to retract. We can see, therefore, that electronegativity increases a little bit as you go up a given group on the periodic table, and this phenomenon is called the shielding effect. Fluorine is therefore the most electronegative element on the periodic table. It's up in the upper right corner. The last trend, guys, is ionization energy. Break it down. Ion means atom with a charge. To ionize something means to give it a charge. One way to do that is you can steal an electron, and then you leave it with a positive charge. So ionization energy means the amount of energy needed to steal an electron. How much energy does it take to take an electron from an atom? Now, this is almost the same trend as how much love you have of electrons. If you love electrons, it's going to take a lot of energy to steal an electron from you. So we're going to see almost the same trend. Ionization energy increases as you go to the right on the periodic table because of the octet rule. And it increases a little bit as you go up because of the shielding effect. The big difference comes when you talk about the group 18 elements here called the noble gases. Over on the right, helium, neon, argon, krypton, and xenon, and radon. These elements have 8 valence electrons. They have the perfect situation. They have a full outer shell. Which means, if we're asking about electronegativity, do they want more electrons? No, they don't. The noble gases have very low electronegativity. On the other hand, it's going to be very difficult to steal an electron from these atoms because they have the perfect electron configuration. And that means that they have a very high ionization energy. So while the trends of electronegativity and ionization energy both increase as you move to the right and up the periodic table, they drastically differ when you get to the noble gases. Electronegativity drops to 0, and ionization energy remains very high. That's it for today, guys.